welcome all. Good afternoon. As the scientific coordinator of the Center for Philosophy of Science of the University of Lisbon, I'm delighted to open this session of our permanent seminar. This time again in hybrid format. I think that we will maintain this kind of format. Okay. Today's speaker will be Professor Elena Casetta. Elena was a postdoc from FCT grant holder with us here at the Center for Philosophy of Science from 2013 to 2017. And she was also the PI of the FCT project, Biodecon, which biodiversity definition for biodiversity conservation. And you are still a member of a project that we have with, yeah, exactly, on emergence with David, Davide, Gilles, and Danny, myself. So you were the PI of the FCT project from 2016 to 2019, and then you decided to leave us, and you are now an assistant professor at the Department of Philosophy and Education of the University of Turin. And we still have the pleasure and honor to have you as our collaborator. So I just want to thank Elena for having accepted our invitation to do this session. It's a great pleasure to have you again here with us.
Thank you very much for having me. I'm quite thrilled, and also, can you hear me? I hope so. Okay. Okay, so I'm quite excited, thrilled, also a bit anxious of being here again. Speaking in front of friends is often more difficult than speaking to unknown people. So, the title of my talk today is Are Ecosystems Becoming Units of Selection? And I hope that the title will become clearer during the talk. Let's start. Okay, it is divided in three parts. And the first question that I'm going to ask is, can ecosystems be units of selection? Let's give, let's say, a very general background, okay? And we're speaking, of course, about the theory of evolution, right? And here I'm taking as a departure point a formulation that Hull gave in his classical paper on species as individuals in 1976. Unmute to start speaking. Do I have to do something? Yes, I can't see. No, sorry, I can close it. Okay, sorry. And Hull in 1976 wrote, according to one time honored Thank you very much. Okay, according to one time honored formula, genes mutate, organisms compete with each other and are selected, and species evolve. To put the matter dramatically, the gene is the unit of mutation, the organism is the unit of selection, and the species is the unit of evolution. Okay. And this is, let's say, a graphic representation coming also from the top. Right? So, mutation happens at a certain level, okay, which normally is the level of genes, selection at the level of organisms, and evolution at the level of populations or species. So we are speaking of three different, somehow topics. So when we ask the question whether can selection act at the level of ecosystems, we are not asking, in my opinion, the question whether ecosystems evolve. Right? These are two different questions. And in the first part, I'm just focusing on the first question. Can selection act at the level of ecosystems? So we are at this level, okay? Then in the second part, we are going to speak a bit about the possibility of ecosystems evolving. But now let's just focus on the first question. whether selection can act at the level of the system. Okay, and here I am, let's say, another starting point is another general starting point is the idea that has been put beautifully, according to me, by Wilson and Sober. The idea is that collections of individuals can become functionally organized by natural selection in exactly the same way that the individuals themselves become functionally organized. Right? So as organisms became functionally organized through evolution by natural selection, maybe there are other things that can become functionally organized through evolution by natural selection. So this is, let's say, the general framework, and this is the question that I'm going to ask myself at first. And let's start with someone who answered positively, in the positive to the question whether ecosystems can be units of selection, which was Max Dunbar. He wrote that selection may apply at the level of the ecosystem as well as at the level of the individual. Ecosystems can compete. So he had quite a traditional view of evolution in which ecosystems can be units of selection, they can compete, and let's say their frequency changes through time or something like that. We are going to see that. This is let's say a fictional example that he gives. I've changed it a little just to underline the parts that I'm more interested in, but it is faithful. So he suggests, suppose that an ecosystem, E1, begins to develop population oscillations to a lethal degree. And so he explained a lethal degree means to the extent that one or more vital parts of E1 are not able to survive. What happens? He suggests that the resulting empty environmental space is available for occupation by communities coming from other ecosystems, which are close to the first one, especially close to the first one. Okay, let's say ecosystems E2 and E3. Now, since E2 and E3 are surviving while E1 is not, okay, they are similar, but they are not precisely the same. They're not of precisely the same constitution as E1, so there is variation. One or more of their components will have some property favorable to the continuous survival of the system. As examples, he gives, because he's speaking of ecosystems in cold regions. Okay? So as examples, he gives a growth rate, breeding potential, and or metabolic adjustment system. So his idea here is that, yes, the systems can be units of selection, and that they compete for occupation of space. Okay, what he has in mind is a sort of, let's say, the idea is that ecosystems are quite similar to organisms. Okay. And that there is a variation and that they compete. And then he adds the following. In this way, the system dominant in any geographic region changes and changes in the direction of greater stability. And the thesis here is simply that there is a selection acting constantly in favor of great stability. Now, these last two claims, we are going to see them in the second part of the talk, because it seems to me that the first part has to do with selection, while the second part, the one in gray, has more to do with evolution by nature. And we are going to talk about that in the second part of the talk and in the conclusion. Now, probably Dunbar was not right about the idea that the systems evolve towards great stability. We are going to talk about that a little. But maybe it is worth it to consider the idea that ecosystems can be units of selection, and that somehow the system can, let's say, the frequency of ecosystems that can change through time. Okay, so if we are asking the question whether ecosystems can be units of selection, of course we can ask what criteria something has to meet to satisfy in order to be said a unit of selection, right? So first, normally it's considered to be having a certain sort of organization, okay, which is an organism-like organization, because the paradigmatic units of selection are organisms, and then we expect that the units of selection have a kind of organization similar to that of organisms. The second criteria is, in a way, more trivial, which is the fact that there must be more than one unit, and they must be diverse. Otherwise, selection has no material on which to act. I would say, I said it's in a way more trivial, and I'm not going to talk about these condition. Actually, it's not so trivial in the sense that evolution can also occur in principle among the parts of a unit, right? So it would be an intra-individual selection, but we are not interested in that in this. I'm not interested in that. And then the third condition is that the units being selected must show differential fitness. And normally, traditionally, fitness is defined as the success of an entity in leaving descendants to the next generation. And of course, ecosystems do not do in the standard way, in the way that we consider to be the standard way, right? So let's see whether what that can mean what that can mean having a certain sort of organization, and what can be a kind of fitness for ecosystems. Okay. So the first move normally when the question whether ecosystems can be units of selection is asking whether fitness can be understood as a persistence. Okay, because ecosystems do not reproduce, but of course they persist through time, right? And I think that this is feasible. First, for several reasons. So it is feasible, in my opinion, to understand fitness as a persistence. As I was saying, for several reasons. First is that because Darwin allows it, in the sense that in the Darwinian theory, the two different meanings of fitness coexist. So at least according to Eldredge, but I think that this is quite a plain claim. So an organism, the fitness of an organism is its capability of surviving and reproducing. The second reason is that it seems to me that there is a bunch of literature very convincingly arguing for it. I'm not going through that, but I wanted just to give some reference, like Bouchard, Dussault, Doolittle, and Baptiste and Papal, etc. And plus, this is more, I think, more controversial. I'm not entirely sure about that, but I think that unlike evolution, selection is not per se a cross-generational process. And if you think about that, for instance, Brandon, in his book, was Environment and Adaptation or something like that, he articulated the process of evolution into 3 steps. Okay, so first the selection, second reproduction, and then development. And I think it's quite right, at least conceptually, at least selection, you can have selection without reproduction because let's say if you buy into a propensity interpretation of reproduction, so capability of, let's say. But I'm not entirely sure about that. So we can discuss that during the. So these are, in my opinion, quite compelling reasons for understanding fitness as persistence. And we can buy into a sort of definition on this kind, which is A is fitter than B, where A and B, for instance, are ecosystems. In E, which is a common environment, if A is better able to persist in E than B. But of course, for instance, this can be another reason in favor of understanding fitness as persistence for ecosystems, because also Tansley, who introduced the concept of ecosystem, somehow suggested to interpret it in that way, right? Because he wrote, they all show, he is referring to ecosystems, and he wrote that they all show organization, which is the inevitable result of the interactions and consequent mutual adjustment of their components. There is, in fact, a kind of natural selection in incipient systems, and those which can attain the most stable equilibrium survive the longest. Of course, the Tansley view can be questioned. Tansley view makes the reference somehow to the paradigm of equilibrium of nature, so to the idea that ecosystems develop until at a certain point, and that point is a point of equilibrium, etc., etc. But the idea that fitness can be understood as persistence does not depend, in my opinion, on that view. Okay, why? Because actually you can understand the persistence in different ways. Okay, of course, for individual organisms, it's somehow more intuitive to say what persistence is, because it is survival, right? For ecosystem, it's probably more complicated, but there are at least two ways. First one is to understand persistence as stability, and that is, for instance, Tansley and also Dunbar. Okay, so the idea that ecosystems develop until they reach a single equilibrium, which is normally thought to correspond to maximum productivity. Or you can understand it as resilience tensile hauling. Okay, so the idea that there's not just the one stability, let's say one state of stability to be reached, but that different stability domains are possible, and you can measure the magnitude of disturbance that can be absorbed before the system changes itself. So this is how you can, maybe there are other ways of understanding persistence in ecosystems, but I think that these two are the more reasonable ones. So first point, I think it's quite. I think that we have quite good reasons for not exclude at least the hypothesis that the fitness can be understood. Now, what about organism-like organization? Do ecosystems show an organism-like organization? Yeah, and so here I'm re-quoting Wilson and Sober. The idea is that individual organisms can be seen as groups of genes that have become functionally organized by natural selection, perpetuate themselves. So if that happened for individual organisms and genes, if that happened to genes, and why that cannot happen for collections of individual organisms to become functionally organized by natural selection as well. And This is called Bouchard called this definition of individuality, the common fate definition. There are others. One is the Dupré-O'Malley definition that, according to them, there can be, let's say, the functional integration. I mean, they're speaking about the multi-species communities mainly, right? And you can see multi-species communities as individuals made of a variety of lineage-forming entities which are functionally integrated, okay? But there is a problem here, which is in fact that they're speaking mainly of superorganisms and multi-species communities, okay? That somehow form, at least the multi-species communities somehow are made of entities, units that form lineages, right? Well, that is not so intuitive for ecosystems. Yeah, so that is the elephant in the room. Ecosystems include also abiotic entities, right? Which by definition do not respond to selection. Okay, but here, Philippe Hünemann came up with, I think, a very beautiful solution, which is to distinguish a strong concept of individuality from a weak concept of individuality. That applies, and he thought about in formulating his weak concept of individuality. He had explicitly in mind all the ecosystems. While on the contrary, for instance, even though both the other concepts of individuality that I've mentioned, they usually make reference to the possibility of applying that concept also to ecosystems, but actually the examples that they give are normally examples of multi-species communities, like bacterial biofilms or clonal organisms, superorganisms, etc. So while on the contrary, Hünemann, speaking of his providing his weak concept of individuality, he was thinking of ecosystems, and his idea is that you can distinguish an individual system if the interaction between elements within the system are stronger than those with the external elements. I'm not going into details here because I would just to point at the fact that a concept of individuality, or in a way an account for a certain kind of functional integration of a system made of both biotic and abiotic components, can be provided, and it has been provided. So let's now transition towards the second part, okay? In the second part, I'm gonna show an experiment in which artificial ecosystems can be units of selection, okay? And then we are going to ask in the conclusion, which are very provisional and to be discussed, etc., whether weak individuals, in Hünemann's sense, so to speak, so individuals defined by means of the strength and frequency of the interaction among parts, okay, can become units of selection. So if they can become stronger individuals. So an experiment has been made, and here we are going to speak a bit about the second question that I introduced at the very beginning. So if a population of ecosystems can evolve by natural selection. The example has been the experiment has been made by Swenson, Wilson, and Elias in 2000. I think it's an interesting experiment. What I don't know is why there, at least to my knowledge, there has not been a follow-up of these experiments. Maybe there are. I couldn't find it. So what they did was a selection to perform a selection of soil ecosystems for the phenotypic trait of above ground plant biomass. Okay? So they used as a phenotypic trait of the ecosystem above ground biomass. They defined ecosystem as the interaction of species with each other and their physical environment. So they say, okay, since we defined ecosystem in that way, and above ground plant biomass is likely to be mediated through effects on the physical environment, then our experiment qualifies as selection at the ecosystem level. Seems convincing to me, but maybe it's not. I don't know. So what they did was artificial selection on artificial ecosystems. Okay. So what do you need to perform such an experiment? First, you require a population of units, right? Because in order to have evolution, you need a population. Okay. And it's not very clear if you have populations of ecosystems. But artificially, you can have them, right? You can make them. So they used as their population was made of 15 transparent containers designed to grow plants under microbially controlled conditions. Okay. These are actually, the picture doesn't come from the paper, but I've checked, so that should be, those should be the containers. But of course, the soil is not white. Each container is filled with 85 grams of sterilized watered potting soil, which represent the abiotic component. And it is not clear whether they consider, they do not specify that, or if they consider the container as a part of the ecosystem or not. I don't think so. Then they added 50 seeds of surface sterilized Arabidopsis thaliana, which is a model organism for plants because it reproduces, it grows fast. And the plants were then allowed to grow under continuous light at 25 degrees for 35 days. And that was considered to be one generation. Okay. Of course, it is artificial because you make a population, okay, and you decide how one generation lasts. Then for evolution by selection, another ingredient is required, of course, which is a method to create the follow generation, the sequence generation, okay, from the selected parental unit. So here, fitness is understood traditionally as reproduction. So, and what they did was to take the 3 ecosystems among the 15, okay, with the highest and the 3 with the lowest value of the phenotypical trait. And they were selected as parents. They were the parent entities. Okay. Then they took 6 grams of soil coming from each of the 3 parents. They mixed it. And they used that soil to inoculate the offspring generation of units. And while seeds are added anew at each generation. And they did this for 16 generations. Okay, so what they did was to create artificially a lineage of subsequent generations of ecosystems. What is the result? And here I'm going to just, this is a modified picture because actually the experiment considered both soil ecosystems and marine ecosystems, and it was more complicated than how I am presented, but so I'm presenting just, let's say, a selection of the a part of the experiment, but it is faithful, at least I hope. And these are the results. So the line above is, okay, this is the representation of the phenotypic trait that has been considered, okay? And the line above is let's say, the selection for higher biomass, and the other one is the selection for the parents with the lower biomass, okay? So first condition, the ecosystem vary in the phenotypic trait that is being selected. Yes, because in the two line diverge. Okay. And second, you must be sure, of course, that phenotypic variation is caused by underlying properties of the ecosystem, so that is not a coincidence, okay? And they tested the soil chemical properties for 2 generations, 13 and 14, and the results were that they were clearly different. There were clear difference between the high and low lines in those chemical properties that plausibly affect plant biomass, like potassium, zinc, and phosphorus content. And finally, offspring ecosystems, in order to have evolution by natural selection, okay? Finally, offspring ecosystems must partially resemble their parents in their effect on the phenotypic trait. And the two lines diverged considerably for some generations. So you have, I mean, generation 30, generation 11, 12, 13, 14 are very similar to each other, okay? While there has been a collapse in generation 15 because of a fungus, okay? But then, so everything died, but then it restarted with the same divergence. So these are the conclusion of the experiment. The author said that traditionally ecosystems have been envisioned at a larger spatial scale, like a forest, lakes, the whole heart, okay? And that the natural ecosystem selection is unlikely to occur at these scales, and is theoretically impossible for the whole Earth. Because when speaking about selection at higher levels, like ecosystems, for instance, the worry is always, yeah, you're speaking about, I don't know, Gaia hypothesis or stuff like that. Okay. However, they say, by miniaturizing the concept of ecosystems, it becomes possible to envision a process of natural ecosystem selection very similar to our experiment. So what they say is that, yeah, if you miniaturize the concept of ecosystem, you can have selection. You can have ecosystems can be units of selection. Ecosystems can evolve by natural selection, and maybe you can think about that also at the level of also considering natural ecosystem selection. And actually, they conclude saying that artificial ecosystem selection encourages us to look for a similar process of natural ecosystem selection. And actually, if you think, when Darwin wrote The Origin of Species, he started with artificial selection, right? And he said, yeah, okay, since we can perform artificial selection, then maybe we can look at nature. We can look in nature for a similar process. Right? Okay, and so let's go to the conclusions, which are, as I was saying, quite sensitive. And the final question is, which was also the title of the talk: are human beings favoring ecosystems becoming units of selection through ecological engineering? Ecological engineering is, let's say, the practice of designing, restoring, managing ecosystems, okay, which is becoming more and more important today. And I think that this is a question, the question whether we are favoring ecosystems becoming units of selection. I think that this is a question worth asking today. Why? Because seems to me that a framework is emerging, at least in European Union, concerning environmental policies, in the sense that they are more and more focused on ecosystem services. It has been a while, but I think that this trend is stabilizing, so to speak. Ecosystem services are the services that ecosystems provide to us through their functioning. And for instance, if you look at the recent legislative proposal for the EU Nature Restoration Law, it has been called the Nature Restoration Law, and it has been made in June 22. But actually, if you read the law, it is a proposal for ecosystem restoration, okay, including sea ecosystem, land ecosystem, and also agro ecosystems, okay, which are nature more or less. So, in the law, it is written that the proposal does pave the way for a broader range of ecosystems in the EU to be restored and maintained by 2003. But, and here is my question, and the topic that I would like to discuss with you. Of course, restoring ecosystems, managing ecosystems has a lot of constraints, right? Because the resources are limited. Okay, so which we need to pick up which ecosystems to restore, right? And for instance, a lot of attention has been paid recently to those ecosystems that can be worked better as carbon sinks, right? And more generally, we focus on useful ecosystems. So those ecosystems that can provide those services that we need and we like. So the question is whether restoring some ecosystems rather than others, we are increasing the frequency of certain ecosystems in the, let's say, ecosystems global population, okay, as Dunbar was somehow suggesting. And if maintaining them, managing them, that is increasing their persistence, okay, we are artificially increasing their differential fitness, understood as this. So that is the, let's say, the sense of the question: are we making certain ecosystems units of selection? Are we somehow artificially, but not entirely, because those ecosystems are not built in a lab, as in the experiment that we have seen before. So if we go back to the last two claims by Dunbar that I presented at the beginning, in this way, if we are actually doing that, the system dominant in any geographic region changes, and changes, okay, I wouldn't say in the direction of greater stability, because we are selecting ecosystems mainly because of their productivity, okay, or for some specific ecosystem service that not necessarily depend on stability. So Dunbar was probably wrong about stability. However, maybe he was not entirely wrong in the idea that ecosystems can be units of selection. And this is just in the very conclusion, a sort of way of putting the argument that of resuming the argument that I tried to present today. And I hope that it works. If it doesn't, you're very free to tell me. Okay, so first, we have to admit that novel units of selection can evolve by natural selection. Okay? And this is quite an uncontroversial claim, I think. Then we need to admit the possibility that ecosystems satisfy the requirement for being units of selection. And it seems to me that that possibility has not been ruled out, so that they can be units of selection. Then we have showed that through the experiment that artificial selection can act on artificial ecosystems. And we have suggested that possibly through ecological engineering, human beings are artificially selecting ecosystems, okay? But since the human beings are a part of nature, artificial selection is a type of natural selection. So maybe ecosystems are becoming, because of us, a unit of selection. And if we are making ecosystems a unit of selection, the direction where our selection is or should be going seems to be something to be thought about, in my opinion. And that's all. Thank you very much.